Okay, so for the first one, we have linear, which is the formula that I picked, or the molecule I picked was CO2. So right now I'm currently drawing out the Lewis dot structure. And then as you can see, I'm putting down the valence electrons. And then if we look at our periodic table for C, it's going to go ahead and be 1, 2, 3, so it will be 4. And then for O, it'll be 1, 2, 3, 4, 5. It'll be 6. And we're going to times that by 2. So we have 4 valence electrons and 12 valence electrons. When we add those together, we're going to go ahead and get a total of 16 valence electrons. So now that we have our total valence electrons, we can go ahead and plug them into our overall Lewis dot structure. So there's one bond, another bond, and then we'll go ahead and subtract 4 since there was 2 bonds, which will give us 12, and that was the total that we got. And then we can go ahead and erase those so that we have them completely balanced out, and then we're going to add on so we have double bonds. So everything is balanced. This would be the shape for this would be a tetrahedral. And then for our bond angles, we will have 180 degrees. Right now I'm doing the delta notation as well as our polarity arrows for each atom and bond. As you can see, this is a non-polar covalent bond, and our overall polarity is non-polar. And then for our hybridization, we have sp, and then our formal charge is 0 since carbon has 4 valence electrons. And this is the same for both of our oxygens as well. If we go ahead and look at my 3D model, you can see carbon in the middle and then the two O's for oxygen on each side. And I also went ahead and made the double bonds with the sticks, and then we also use the little drops as the candy. For our next one, we have the trigonal planar, and the molecule that I chose was SO2. This is also sulfur dioxide. As you can see, I'm putting down the total valence electrons. So we did for oxygen, we have 6 times that by 2, and we're going to go ahead and get 12. And then for sulfur, we'll go ahead and get a total of 6 valence electrons. When we add those together, we're going to go ahead and get a total of 18 valence electrons. Now for the Lewis dot structure, we can go ahead and put 2 bonds, so we're going to go ahead and subtract 4. This will give us 14 now. Now I'm just balancing everything out. And for this specific molecule, we will have other Lewis dot structures that we will have for the Renaissance. So this shape is bent and is the bond angle at 120 degrees. This is a polar covalent bond, and our overall polarity is polar as well. And then for our hybridization, we get sp2. And now you can see that I'm making the other Lewis dot structures since we have more than one. Also, for our formal charge, for every structure, the formal charge on SO2 is going to be 0. And then for our delta notation and polarity arrows, which I didn't exactly put on there for all 3 of them, but S is going to be less electronegative than O, so S will have the negative delta while O has the positive delta, and having the arrows go outward from the atom. So this is my 3D molecule. As you can see, we have sulfur, we have our 2 oxygens, and then we have our bonds. And I only did 1 model, but as you know, there are going to be a total of 3 of these Lewis dot structures, which we showed before. For our next one, we'll be doing the tetrahedral. For my molecule, I went and did NH3. And then as you can see, we're filling out the valence electrons for the Lewis dot structure. And then if we look on our periodic table for H, we're just going to get 1 valence electron. And then we'll go ahead and multiply that times 3, so that will give us a total of 3 valence electrons for H, which is hydrogen. And then for N, we're going to go ahead and get a total of 5. When we add those up, we will get a total of 8 valence electrons. And then we'll take 6 from that since we have 1, 2, 3, 4, 5, 6 bonds total. This will just leave us with 2 valence electrons left to go ahead and fill in for our Lewis dot structure. This for the shape is a trigonal pyramid with our bond angles at 109.5 degrees. This is a polar covalent bond, and then our overall polarity is also polar. For our hybridization, we're going to have sp3. And this is what we get for our polarity arrows, as well as our delta notation. And then our N is going to be more electronegative compared to our H, so that would give us a negative delta for H and a positive delta for N. Then again, same thing, this is our 3D model with N in the middle, and then our 3 H's coming out with their bonds as well. For our next one, we have the trigonal bipyramid. The molecule I chose was I3. As you can see, I'm filling out the Lewis dot structure. The total number for I, which is also iodine, is going to be 7. We're going to go ahead and multiply that by 3, giving us a total of 21 valence electrons, but we have to remember to add 1 on since there is a negative formal charge. This will go ahead and give us a total of 22 valence electrons. And then we can go ahead and take away 4 since we have those 2 bonds. I'm now balancing it out using the octet rule. And then of course putting our sign or our formal charge, which is going to be a negative with our brackets around it. For our shape, this is linear. And for our bond angles, this is going to be 180 degrees. This is a nonpolar covalent bond, and overall polarity is also nonpolar. And then for our hybridization, this is sp3d. And this specific molecule in general does not have any polarity. And then again, for our 3D molecule, what we have is the 3 I's, which I'm labeling out right now, and then our 2 bonds going out as well. And then last but not least, we have the octahedral. For this molecule, I went and did BRF5. As you can see right now, I'm filling out my Lewis dot structure. So BR being the middle, and then all 5 of our F's going out. For BR, for our valence electrons, looking at the periodic table, and then for F, we have a total of 7. Multiplying that by 5, we'll get a total of 35 valence electrons. For BR, we should have a total of 7 valence electrons. Adding those all together, we will get a total of 42 valence electrons. We can go ahead and subtract those bonds, so we'll subtract off 10. This now gives us 32, and then we can fill in the rest of them to balance them out using the octet rule. This specific shape is a square pyramid. And for our bond angles, this will be a 90 degrees. This is a polar covalent bond, and our overall polarity is polar. And then for our hybridization, which I'll be writing down, is going to be sp3d2. And then, as we know, F has the highest electronegativity, so all those will be positive delta notations, as well as Br being a negative delta notation with all of the polarity arrows going outwards. And then again, our 3D model with Br in the middle, and all 5 of our F's going outwards, as long as with our bonds as well.